All right, this first lesson in Unit 6-7 factoring. This is called Polynomial Arithmetic, and what we want to do by the end of this lesson is, first off, be able to add two polynomials together by collecting like terms. This is a review of stuff that we did in the early part of the course, but we're going to need these skills going forward, so we'll review them here. We want to be able to multiply a polynomial by a term using the distributive property and the exponent rules. We have used the distributive property before, and we just finished working with the exponent rule, so this should all be fairly straightforward. This is the big thing that we want to be able to do. Multiply two binomials together using what is called the FOIL rule. Now really this is just an application of the distributive property and the exponent rules again, and this FOIL part is just sort of a memory device to help keep us organized. And then finally we want to be able to square a binomial using the FOIL rule. Turns out that's exactly the same as what we did in point 3. So let's jump into it. We've got polynomials here. We got 4x plus 3 and 7x plus 2. These are two polynomials. These are actually binomials because they have two terms. Like one term here, 4x, one term here, 3. 7x is one term, 2 is another term. So two terms makes them binomials. If we are adding these two things together, we really just want to collect the like terms. So our like terms here are the 4x and the 7x because like terms have the same variable with the same exponent on it. Our variable is x, our exponent is just 1, so we'll have 4x plus 7x, and the 3 and the 2 are also like terms, so 3 plus 2. And then we can combine the like terms together. 7x plus 4x gives us a grand total of 11x's. 3 plus 2 gives us 5. And we can't combine the 11x and the 5 together because, again, they are not like terms. So we want to combine only the like terms. All right? And we can make it more complicated. Here we've got two 3-term polynomials. These are trinomials because they have 3 terms. But again, we just want to match up the like terms. So negative 2x squared and negative 2x squared, same variable, x squared, with the same exponent 2. So those are like terms. Let's collect them together. We've got a negative 3x and a positive 4x. Remember, those signs stay with that term that they're on. So I'm going to write that as a negative 3x and a positive 4x. And our last two terms, the 7 and the 6, are like terms because they're just pure numbers. So adding our like terms together, negative 2x squared and negative 2x squared, negative 4x squared. Just adding those coefficients. Negative 3x plus 4 would be plus 1x, or just plus x. 7 plus 6 would be 13. Okay. So adding terms using, by combining the like terms. Multiplying a polynomial by a term. So this is us using the distributive property. And if we've got something like 2 times x minus 5, the distributive property says we're going to take whatever we have in brackets, and everything in those brackets is going to get multiplied by that too. So 2 times x plus 2 times negative 5. And then we do our multiplication. 2 times x is 2x. 2 times negative 5 is negative 10. And we can't combine those two terms together because they are not like terms. If we see something like this, we imagine that there's a negative 1 out in front. That negative sign all by itself, think of it as a negative 1. Everything inside the brackets gets multiplied by that negative 1. So negative x squared, negative 2x. Negative 1 times negative 5, positive 5. The distributive property applies even if we have a term out in front rather than just a single number. So if I've got x times x squared minus 2x, I'm going to take that x and I'm going to multiply it by x squared. I'm going to add x times negative 2x. And when I'm doing this multiplication, I'm going to apply those exponent rules. I've got powers of the same base. The base is x, so I'm going to add the exponents. 1 plus 2 gives me a 3. my next term here, I've got a -2 as my one coefficient. It'd be like a 1 as my other coefficient. So I'm going to have a coefficient of -2. X times x gives me x squared. Again, just adding those two exponents together. We can make it a bit more complicated by putting a coefficient on our term out front, but it's still going to be -4x times 2x squared plus, again, -4x times -3x. -4 times 2, -8. X times x squared, x cubed, just adding those exponents. -4 times -3 is +12. X times x, x squared. And again, we can't combine those two terms together because they are not like terms. Now, what if we have something that looks like this? X plus 1 times x plus 2, where we've got a binomial, x plus 2, multiplied by another binomial, x plus 1. We can do this using the distributive property. So remember, the distributive property says, I'm going to take what's in the second bracket, x plus 2, and I'm going to multiply it by what's out in front. So the x plus 1. What this means is that each term in the second bracket, the x and the 2, get multiplied by both of the terms that are in the first bracket, both by the x and by the 1. So my x here gets multiplied by x and 1. My 2 gets multiplied by x and 1 as well. This FOIL rule is just a way of keeping all of the multiplication that we have to do kind of organized, okay? Also, this is called expanding. We're taking two things that are multiplying together, and we're writing it as a bigger polynomial. Okay. So what does this FOIL thing mean? Well, FOIL just is just referring to the terms that you're multiplying together. F stands for the first two terms. So the x and the x, the first term in each bracket, we are going to multiply those two things together. So that's going to get us x times x. Those are our first two terms. Next, the O stands for the outside two terms. So that's our x, and this one all the way on the other outside, the 2. So we're going to add x times 2. Those are our two outside terms. I stands for the two inside terms. So that's going to be the 1 and the x. So to this we are going to add 1 times x. Those are our inside two terms. And the L stands for the last two terms. The 1 and the 2. So we're going to have 1 times 2. Those are our last two terms. Okay, so this FOIL is just a way of reminding you that you need 4 multiplication things here. And then we just combine the terms like we were doing on the last slide. X times x, x squared. X times 2, 2x. 1 times x, 1x. 1 times 2, 2. And then usually when we use this FOIL on two binomials, we have two terms here in the middle that are like terms that we can combine together. 2x plus 1x gives us 3x. So x squared plus 3x plus 2. And again, we can't combine any of those because they are not like terms. So let's look at another example here. We've got a plus 3 times a minus 4. We're going to start off by doing, again, our first two terms, a times a. Our outside two terms, a times -4. Our inside two terms, 3 and a plus 3 times a. And then finally, our last two terms, 3 times -4. And we'll do our multiplication here. A times a gives us a squared. A times -4, -4a. 3 times a, 3a. 3 times -4, negative 12. And just like before, these two terms in here are like terms, so we can combine them together. Negative 4a plus a would give us a negative 1a minus 12. And that's the FOIL rule for multiplying two binomials. So here we've got two binomials, 3y minus 2 times 4y plus 1. You might want to pause the video, try this one on your own, and then start it again to see if you did it correctly. I'm going to start with my first two terms, 3y times 4y. So 3 times 4 gives me 12. Y times y squared. My outside two terms, 3y times 1, 3y. My inside two terms, negative 2 times 4y, negative 8y. And then my last two terms, negative 2 times 1, negative 2. Collecting my like terms in the middle, 3y minus 8y minus 5y minus 2. If they give us something like this, 3 times x minus 3 times x plus 5, I would do this in two stages. The first stage would be distributive property on the first bracket. 3 times x is 3x. 3 times negative 3 is negative 9. That's going to stay in brackets, and we're going to multiply that by x times 5. Now we're going to do our FOIL on these two binomials multiplied together. 3x times x is 3x squared. 3x times 5 is 15x. Negative 9 plus times x, negative 9x. Negative 9 times 5, negative 45. And again, we can collect those two like terms in the middle. 15x minus 9x is 6x. So 6x minus 45. What if they give us something like this? A binomial, x plus 3 squared. Well, we know what the squared means. It just means take something and multiply itself. So let's write this as x plus 3 times x plus 3. We know what to do here. We can use our FOIL rule on this. So x times x, x squared. X times 3, 3x. 3 times x, 3x. 3 times 3, 9. Collect our like term in the middle. 3x plus 3x is 6x plus 9. Okay. So here's another one where you might want to pause the video, try it on your own, and then check to make sure you've done it correctly. We'll start by writing this as 2a minus 1 times 2a minus 1. And then FOIL. 2a times 2a, 4a squared. 2a times negative 1, negative 2a. Negative 1 times 2a, negative 2a. Negative 1 times negative 1, positive 1. Collect our two like terms in the middle. Negative 2a minus 2a, negative 4a, and then our plus 1. So one special case of applying this FOIL rule to multiply binomials is what happens. Are these things called conjugate binomials? So what does this mean? Let's take an example here, x minus 2 times x plus 2. Let's just see what happens when we apply FOIL here. X times x gives us x squared. X times 2x, x times positive 2, positive 2x. Negative 2 times x, negative 2x. Negative 2 times positive 2, negative 4. When we go to collect our like terms, we notice that the 2x and the negative 2x are going to cancel each other out. So this would be like x squared plus 0x minus 4, or just x squared minus 4. So instead of getting a trinomial like we got here and here, these are trinomials. Okay, because they had three terms in them. This time we ended up with just two terms. We ended up with a binomial. Okay. So this is always going to happen when you have what are called conjugate binomials. What does this mean? Well, conjugate binomials have the same first term in the two brackets. They have the same sort of thing here and here at the end of the brackets. But what is different is the sign on the two, in between the two of them. We have here and here opposite signs. And that's what makes it the conjugate part. So a negative sign in the first bracket, a positive sign in the second bracket. Okay, and that gives these two middle terms opposite signs, so they cancel out. So let's look at this example over here on the right. We have conjugate binomials, okay, because we have a 3x here and a 3x here, and we have a 1 and a 1, but we have a negative 1 and a positive 1. So same terms with different signs. We know what to expect here, but we're going to expand this using our FOIL rule anyways. 3x times 3x, 9x squared. 3x times negative 1, negative 3x. 1 times 3x plus 3x. 1 times negative 1, negative 1. And those two middle terms will give us a 0x or 9x squared minus 1. Okay. So if you're sort of paying attention, you'll notice that this first term here, this 9x squared, is 3x all squared, right? 3x all squared is 9x squared. The 3 gets squared and the x gets squared. This last term here, this 1, is 1 squared. Right? So we started with a 3x and a 1 in both brackets, just with opposite signs. Our final answer here was that first term squared. This is always going to be subtraction. And our second term was just that second term squared.